Welcome to C and C++ programming under EPG Pathshala. Today we will start with module 38, working with files. We have written many programs in C++ till now. Whatever programs we have seen, the input was taken from the keyboard and the output was written on the screen. This is possible if our input data is small. In a program, if you are going to read the large amount of data, then it is difficult to key in this data every time when we run the program. So, we need some solution to this particular problem. Even our data which is written on the screen will be lost once the computer is turned off. So, the solution to this particular problem is files, where our input data or output data can be stored permanently into the storage. These files can be stored on a hard disk or on a secondary storage. A file can be treated as a sequence of characters. It is stored on the hard disk. There are three steps which are required to deal with the files. These are: open the file, second, read or write the data to the file, and third, close the file after the use. There are two types of files in C++. These are mainly text files and binary files. In text files, the data is written in a readable format where each line of text is terminated by end of line character. In binary file, the data is in non-readable format. It is in the format where actually the data is stored on the hard disk. In C++, the files are treated as streams. Streams is nothing but a channel on which a data will flow from a sender to receiver. Stream is a term which is used for the flow of data. There are three types of streams in C++. These are IF stream, which is used to read the data, OF stream, which is used to write the data, and F stream, which is used for read and write purpose. In our C++ program, we have used cin and cout, which is basically standard input stream and standard output stream. Now, let us start with our module and see something more about files. The files are a way to store data permanently in a storage device. The file handling mechanism in C++ offers a way to store the output of a program in a file and to read from a file that is available on a disk. The IO stream header file provides predefined objects such as cin and cout to take the input from the keyboard and to write the output to a console. The header file fstream is a header file which gives the data types or classes of type ifstream, ofstream and fstream, which can be used to read the contents from a file and to write the contents to a file. Now, let us see the learning objectives of this module. We will get familiar with file streams, we will learn about file streams, we will study about operations on files. We will learn about reading a character to a file and writing a character to a file. We will study about file pointers and their manipulations. We will learn about reading and writing a block of data. We will study about reading and writing objects. We will learn about random access files. We will get familiar with error handling during file operations. Now, let us see file streams. In C++, all the input and output operations are performed with the help of streams. In general, a stream is a series of bytes that flows from the input-output device to the program. In C++, the operations on files are carried out in a similar manner as that of console input and output operations. A file stream is an interface among the programs and files. The stream that provides the information to the program is referred to as the input stream. The stream that obtains the information from the program is referred to as the output stream. In general, the input stream tries to read information from the file, whereas the output stream tries to write the information to the file. In C++, it is possible to open a file by connecting it to a stream. Now, this slide represents the file input and output diagrammatically. So, as you can see in this particular diagram, the input device, the data is flowed to the input stream, which is basically nothing but a channel. It is given to the program. The program will write it to the output stream and then it is written to the output device. So, here the two streams are shown as input stream and output stream through which a data will flow. The file streams in C++ that are used for file handling operations are fstream base. It offers operations that are universal to file streams. It supplies as a base for fstream, ifstream and ofstream classes. It includes open and close functions. File buff. It carry out the input and output operations with files. The main task of it is to set the files buffers for read and write purpose. It also includes open and close as member functions. ifstream. It offers input operations. It holds open function with the default input mode. It can access the member functions like get, getLine, seekg, tellg and read. ofstream. It offers output operation. It holds open function with the default output mode. It can access the member functions like put, seekp, tellp and write. fstream. It permits instantiation input and output operations on file buff. The input and output is carried out by member functions of the base classes istream and ostream. It holds open function with the default input mode. Since the above classes are defined in fstream.h or fstream, therefore, to use any of these classes, it is must to include the fstream.h or fstream statement in the program. In general, there are two types of files, that are sequential access files and random access files. Now, let us see the sequential access files. It is a must that these files are accessed in the same order in which they are written. This process is similar to audio cassette tapes, where it is a must to do rewind or fast forward through the songs in sequence to get a particular song. In order to access data from a sequential file, it is must that a search should start from the beginning of the file, and search can be done through the entire file or the data which is required. Random access files. These types of files are similar to audio compressed disk, where it is possible to access any song in spite of the order in which the songs were recorded. The important feature of the random access files allows us to access any data in the file, but the disadvantage is that they occupy more disk space than sequential access files. Now, let us see different operations on files. Some of the operations that can be performed on files are opening a file, closing a file, reading from a file, writing to a file, checking for end of file condition. Opening of a file. Some of the commonly used file opening modes are ios::in. It will open the file for reading purpose. ios::out will open a file for writing. ios::app will append the data to the end of the file. ios::ate, the file pointer moves to the end of the file, but it allows to write data in any place in the file. ios::trunc, if the file already exists, then its contents will be removed before opening the file. It is a must that a file should be opened before the information is read from it or before the information is written into it. The ofstream object or fstream object is used to open a file for writing, whereas ifstream object is used to open a file for reading. Syntax is void open in bracket constant char star file name comma ios : open mode and the mode. In this particular syntax, the first argument indicates the name and the location of the file that is to be opened. The second argument of the open member function identifies the mode in which the file should be opened. It is possible to join two or more these values using OR condition. Example, ofstream ofs, ofs.open first file.dat in double quotes, comma ios::out or ios::trunc. Second example can be fstream fs, fs.open text file.txt in double quotes, ios::out, ios::in. So, here this file will be open for reading as well as writing purpose. Closing a file. When a C++ program ends, it involuntarily closes and flushes all the streams and release all the memory that is allocated, and it also closes if any open files are there. The syntax is void close. Example is fs.close or ofs.close, writing to a file. To write the information to the file from the program, it is must to use an ofstream or fstream object instead of the cout object. It is must to enter the file name with extension to open that file with the help of function open. After opening the file, it is must from the user to enter some contents to store the file. In the end, it is must to close the file by using the function close. Now, let us see a simple program to write the information to a file. We will start with the program #include iostream, #include fstream, #include stdlib using namespace std. Integer main. Now, we will first declare the object of ofstream class as ofstream ofs. Now, we will declare our variables char line of text 100, file name 20. Now, we will take a file name from the user. So, first we will display the message to the user cout enter a file name with extension to create a file. We will take a file name as get as file name. Now, we will open this particular file ofs.open file name. Now, we are going to write with our logic of this particular program. If not ofs, we will print the error message cout error in opening file exit 0 end of if condition. So, if there is any error in opening the file, it will display the message and it will come out of the program. Next, cout enter the lines which is to be returned to a file. Now, we will write our while loop while string length get as line of text is greater than 0 ofs line of text ofs/n. So, it is going to take a line of text from the user and it is directly going to write this information into the ofs file using the simple statement ofs line of text. So, the syntax is same as our cout statement. Instead of cout, here the object name will be ofs, otherwise everything will be same. Now, our while loop will end, ofs.close will close the file and our program will end. Now, when the above program is compiled and executed, it will produce the result as first it will ask for the file name with extension. Suppose the file name entered by the user is line.txt, then it will ask for the contents to be stored into the file. We will give the contents as it is a first line of text, second line it is a second line of text, third line it is a third line of text and fourth line it is a fourth line of text. Reading from a file. To read the information from the file with the help of the C++ program, it is must to use an ifstream or fstream object instead of cin object. Now, initially we will ask the user to enter the file name with extension with the help of the function open. Once the file name is given by the user, we will read the file contents character by character and show its contents character by character at the time of reading on the output screen. Let us see a simple program to read the contents of the file. Now, in this particular program, we are going to open the file which we have written in the previous program. The same file is going to be open for read purpose. We will start with our program #include iostream, #include string, #include fstream, #include stdlib. Now, we will start with our main function integer main. First, we will declare the object as ifstream ifs. Now, we will declare our two variables character line of text 100, file name 20. Now, we will display the message to the user cout enter the name to read and show the contents, cin fname the name will be accepted from the user. Now, we will open the file ifs.open fname. Now, we are going to print the error message if not ifs cout error in opening the file exit 0 and if condition ends. Now, we will start with our logic of reading from the file. So, we will start with our while loop while ifs.eof is equal to 0, open ifs line of text, cout line of text and end of the while loop. So, now this particular program will read the line of text contents from a file and it will display it on the screen. So, as you can see, this particular statement ifs is same as a cin statement. Next, cout/n ifs.close will close the file and our main program will end. Now, when the above program is compiled and executed, it will produce the result as it is a first line of text, next line it is a second line of text, third it is a third line of text, and last one it is a fourth line of text. Detecting the end of file. It is possible to detect when the end of the file is reached by using the member function EOF. The syntax is integer EOF. The special function EOF returns non-zero, that is true, value when there is no more data to be read from the input stream. Otherwise, it returns 0, that is a false value. Example, ifstream ifs, ifs.open, first is the name of the file, comma, ios in, ios binary, while not ifs.end of file and the while code, or if ifs.eof, cout end of file is reached. Reading a character to a file or writing a character from a file. The two different methods that are available to read and write characters from the file are using insertion and extraction operator on the stream object and using member function get and put. Now, let us see each one of these in detail. Now, let us see the using insertion and extraction operators on the stream object. The insertion and extraction operators can be used not only with predefined objects cin and cout, but they can also be used with f streams. Example, to write a character A to a file stream named OFS, we can write it as OFS, the operator and the A in single quotes. To read a character from a file stream IFS, we can read it as character ch1 IFS ch1. Now, let us see how we can do it using member functions get and put. The stream classes have two member functions that can be used for input and output operations. They are get and put. The member function get is used to read a single character from the associated stream. The syntax is stream object dot get. Example, file dot get in bracket ch. The put operation, the member function put is used to write a single character to the associated stream. The syntax is stream object dot put in bracket character. Example can be file dot put ch. Now, let us see a simple program to read the characters from the file and count the number of lines. We will start with our program, hash include iostream, hash include fstream. We will start with our main program, integer main. First, we will define the object of class fstream. So, we will define the object as fstream ifs. Now, we will open the file using ifs, ifs.open my input file.txt in input mode. So, we are going to write here as ios : input mode. Now, we will declare our variables here, character ch1, integer, number of lines. Now, we will start with our logic, while not ifs dot end of file. We will read from the file inside the while loop. So, we are going to read from the file as ifs dot get ch1, cout ch1, where the characters will be displayed on the screen. Now, we will check whether it is a end of line character. So, we will write our if condition here, if ch is equal to /n, then plus number of lines. Our if loop will end and then our while loop will end. Now, we will display number of lines on the screen as cout, the number of lines in a file are the number of lines variable, return 0, and our main program will end. Now, when the above program is compiled and executed, it will produce the following result as the data in the file will be displayed first as 4 lines, welcome to first C++ program, and the output will be number of lines in the file is 4. File pointers and their manipulations. All the objects of iostream have at least one internal stream pointer. The if stream, like iStream, has a pointer which is known as the get pointer that points to the element to be read in the next input operation. The OF stream, like O stream, has a pointer which is known as the put pointer that points to the location where the next element that has to be written. The F stream take over both the get and the put pointers from IO stream, which itself is derived from both I stream and O stream. The internal stream pointers that point to the reading or writing locations within a stream can be operated using the member functions. They are as follows. Now, there are 4 functions that we are going to see. First is seekg, which will move the get pointer to a particular location in the file. Second is seekp, it will move the put pointer to a particular location in the file. Tellg will returns the position of the get pointer and tellp will return the position of the put pointer. The other prototype for seekg and seekp function is seekg in bracket offset comma reference position. For seekp, it will be seekp offset comma reference position. The parameter offset will give the number of bytes the file pointer is to be moved from the location that is specified by the parameter reference position. The reference position can have any one of the 3 constants that are defined in the iOS class. They are iOS beginning, iOS end and iOS current. iOS beginning will start from the start of the file, iOS end will start from the end of the file and iOS current will present the position of the pointer. Now, let us see a program to obtain the size of the .bin file. Let us start with our program hash include IO stream, hash include F stream using namespace std. We will start with the main function integer main. Now, here we are going to declare 2 variables of stream pose as stream pose begin comma end, if stream ifs test.bin ios : binary. So, we are opening the file in a binary mode. Now, we will start begin is equal to ifs.tellg. So, we are taking the file pointer position into the begin. ifs.seekg 0 comma ios end. So, here we are pointing our position to the 0th position from end. Now, end will be equal to ifs.tellg. So, end will have the value of tellg pointer. Now, we will close it ifs.close. Now, we are going to display on the message on the screen as cout the size of the file is end minus begin bytes, return 0 end of the main program. So, as you can see here we have used this particular 2 variables begin and end. Begin will tell you the position from the first, which is a get pointer, and end will tell you the position from the last, the end pointer, and the difference between begin and end will give you the total size of the file. When the above program is compiled and executed, it will produce the result as size of the file is 40 bytes. Now, let us see a program to implement the usage of tellp and seekp pointers. We will start with the program hash include F stream using namespace std. We will start with the main function integer main. We will declare the variable as long pos, of stream ofs. Now, we will open the file using ofs as ofs.open contents.txt. Now, we will write a contents to the file as ofs.write my name is abcd comma 15. Now, in position we will take the put pointer position as position is equal to ofs.tellp. Now, we will move the pointer as ofs.seekp position minus 4. Now, we will write a new data as ofs.write ria comma 4. Now, we will close the file as ofs.close, return 0 and our program will end. Now, when the program is compiled and executed, it will produce the result as my name is Ria. Now, let us see the concept of reading and writing block of data. The functions that are used to read and write blocks of binary data are read and write. Now, let us first see the read function. The syntax is if stream ampersand read in bracket character star t comma integer n semicolon. The read function reads a block of data of n characters and stores it in an array that is pointed by t. If the end of file is reached before n characters have been read, then the array will have all the elements read until it. Example, to read 3 integers from the file named numbers, we can have the code as integer num3, which is array, ifstream ifs in bracket numbers. Now we are going to read from a file as ifs.read char star num, comma 3 into size of int. So 3 numbers will be read from a file and it will be stored into the array num. The write operation. The syntax is ofstream ampersand write constant char star t integer n. The write function writes the block of data that is pointed by t with the size of n characters into the output buffer. The characters are written in sequence until n have been written. Example, to read 4 floating point numbers to a file f numbers, we will have the array as float fnum3, ofstream ofs f numbers, ofs.write char star ampersand fname, comma 3 into size of fnum. So 3 values of float number array is returned to the file. So as you can see, the syntax of read and write is almost the same and it is easy to use. Now let us see a program to implement the usage of read and write functions on binary file handling. We will start with our program hash include iostream, hash include fstream, hash include stdleave using namespace std. We will start with our main function as integer main. First we will declare the object of fstream class as fstream_fs. We will declare the array as integer num10 and the values of the array 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. Now we will open the file. fs.open integers is the name of the file in input mode, output mode and binary file. So we will have 3 modes as iOS in or iOS out or iOS binary. Now we will write our error opening condition as if not fs cout error in opening the file exit 0 end of if condition. Now we will start with our main logic fs dot write char star num, comma size of num. So now we are writing into the file. Now fs dot seekg 0. So we are bringing the get pointer to the 0th position. Integers 5. Now we are going to read the 5 elements from this particular file. So our statement will be fs dot read char star integers, comma 5 into size of integer. Now we will display whatever we have read from the file onto the screen. So our statement will be cout the contents of the integer array are endl for integer I equal to 0, I less than 5, I plus plus cout integers I. Then we will close the file fs.close, return 0 and our program will end. Now when we compile our program, first it will write all 10 values to the file and it will read the first 5 values from the file. So our output will be the contents of the integer array are 5, 10, 15, 20 and 25. Now let us see reading and writing the objects to a file. C++ program mostly deals with the classes and objects. It is possible to read and write class objects to binary files. When an object is returned to a file, only the data members are returned to the file and the member functions are not returned to the file. The syntax to read an object using a file is as follows. It will be stream object dot read in bracket char star ampersand object name, comma size. The syntax to write an object using a file is as follows. Stream object dot write char star ampersand object name, comma size. Now let us see simple example how to read and write the object. To write an object named E1 of class employee to the file emp, we will do it as emp E1 in bracket 101 comma AAA. So we are giving the values to the object. Now we will open the file ofstream ofs employee. Now we will write this object to the file as ofs.write character star ampersand E1 comma size of E1. So as you can see, the data or the object data is written to the file. To read a single object, of type employee into the object named E2 from the file employee. We will write the code as employee E2, if stream ifs employee. We are opening the file. Now we will read from the file and store into the object E2. So it will be done as ifs.read char star ampersand E2 comma size of E2. Now let us see a program to read and write the employee object to a file. We will start with the program hash include iostream, hash include stdlib, hash include fstream using namespace std. Now here we are going to write the employee class where there will be member functions as get and put and processing details. So these are the three member functions, and then we will start with our main program. So first we will start with the definition of the class employee. Class employee, public, integer employee number, character employee name. Now there will be three member functions. Those will be void put semicolon, void get semicolon, void processing details semicolon. End of the class. Now we will start with the put function, member function as void employee put. We will start with the code of the function fstream fs, cout enter employee number, cin employee number, cout enter employee name, cin dot get line employee name comma 30. So we are asking from the user the employee number and name. Now we will open the file fs.open employee.dat in iOS out and iOS append mode. Now we will write the data that we have taken from the user to the file as fs.write char star this comma size of employee, and then we will close the file as fs.close and we will call the member function e.processing details, and our member function will end. So as you can see here, the employee number and name is taken into the this pointer record, and this record is returned to the file. Now we will write our get function as void employee colon get integer temp, cout enter the employee number, cin temp. Now we will declare the object as fstream fs. We will open the file fs.open employee.dat iOS in mode. So this is open in the input mode. Now we will move the pointer as fs.seekg 0 from the beginning iOS colon beginning. Now we will read from the file while fs.read char star this comma size of employee. Now we will start with the if condition in a while loop. If employee number is equal to temp, then we will cout employee number, cout employee name. End of the if loop, end of the while loop. So if the employee number is going to match with the record that the user has entered, we will display the details on the screen. Otherwise we will go on reading the next record. Now we will close the file as fs.close and we will call a function e.processing details and end of the get member function. The third member function that we are going to define is void employee colon processing details. We will start with this particular member function integer ch, cout enter the choice 1 for input, 2 for output, 3 for exit and endl. We will take a choice from the user as cin ch. Now we will write our switch function as switch ch. Case 1 will be e.put break. We are going to call a member function put. Case 2 will be e.get and break. We will call a member function as get, and case 3 will be exit 0. And our default action will be cout the wrong choice, and our switch will end and our main member function will end. So as you can see here, the main menu will be displayed in processing details. Whenever we go to get function, put function will come back again after processing that to the menu. So unless and until user gives the exit option, the menu will be displayed again and again. Now we will start with our main program integer main. Here we will declare the employee object e and we will call the member function as employee details as e.processing underscore details return 0. When the above program code is compiled and executed, it will produce the following result. First it will display the menu, enter the choice 1 for input, 2 for output and 3 for exit. Then if the choice is 1, then it will display on the screen the data as enter employee number, suppose the employee number is 1, then enter employee name, suppose the employee name is Dipali. Then it will ask the choice again, enter the choice, suppose the choice entered is 2, then it will ask from the user enter the employee number, suppose the employee number is 1, it will read from the file till the employee number 1 is matched, and then it will display the details on the screen as employee number is 1 and employee name is Dipali. Random access files. In order to access the information in a sequential file, it is a must to read from the beginning of the file till the point where the acquired information is available. But it is a time consuming process for large database because they contain huge amount of data. This problem can be avoided by using the new file type known as random access files. It is probable to access any information by omitting as many bytes as required from the starting of the file. The number of bytes that is to be omitted to access any information is called as an offset. The two important functions that can be used to write data and read data in binary format are: the read function is used to read the information from a random access file. The syntax is read in bracket char star ampersand x comma size of x. Second is write operation. The write function is used to write the data in binary format. The syntax is write char star ampersand x size of x. In the above syntax, x is the data to be returned to the file. The first argument to the function is a pointer to a character string. The size of x is the number of bytes that is required for writing x. Now let us see a program to demonstrate the concept of random access file handling. Now here in random access file handling, we are going to manipulate our positions, so that particular code is very important. We will start with our program, hash include fstream, hash include stdlib, hash include stdio, hash include string. We will define our class first of employee. As class employee, we will declare our data members as integer employee number, char employee name 20, char department 3, float salary. Now in a public section, we will declare our member functions. There are 4 member functions. First is accept, second is display, third is get employee number, and fourth one is modify. So first we will write a accept member function where we will accept the details from the user as cout employee number, cin employee number, cout employee name, cin employee name, cout department, cout salary, cin salary. So we are accepting the details from the user here. Void display will display the details on the screen as cout employee number colon the value of employee number, employee name, value of employee name, department, the value of the department, salary, the value of the salary, and display function will end. Integer get employee number is a third member function. It will return employee number and end of the function. Void modify, the actual function body of the modify function will write outside the class. Our class will end here. We will declare 2 objects of this particular class, employee 1 comma employee. Now we will write our modify function here, void employee colon modify. Now here we will display the details on the screen first, cout employee number, cout employee name, department, salary. Now we will ask for the user cout enter new details, char new name 20 is equal to blank space, new department 3 is blank space, float new salary. Now we will display the message to the user cout new name, enter dot to return the old one, cin new name, cout new department, press dot to retain the old one, cin new department, cout new salary, press -1 to retain the old one, cin new salary. Now we are going to compare. If string compare new name with dot is not equal to 0, string copy name dot new name. Next, if string compare new department with dot is not equal to 0, string copy department new department. If new salary is not equal to -1, then salary is equal to new salary and our modify function will end. Now we will start with our main program. First we will open the file fstream fs employee.dat ios in or ios out. So, we will start with the declaration char ch equal to y. While ch equal to y or capital Y, employee 1 dot accept will accept the details from the user. We will write these details to the file as ifs dot write char star ampersand employee 1 comma size of employee 1. Cout record is added to the file. Cout want to enter new record yn cin ch. So, it will read from the user the input data and it will be returned to the file unless and until user gives the no option. Then we will write a code for the modification using the random access. So, our code will be integer e number long position character flag equal to f. Cout enter the employee number of employee whose record is to be modified. So, now we are going to ask the employee number as cin employee number. We will ask the employee number from the user, we will find that employee number into our file and that employee number directly will be modified. This is basically the random access logic that we are going to use. ifs.seekg 0 while not ifs.end of the file, position is equal to ifs.tellg, ifs.read char star employee 1 comma size of employee 1. So, we are reading from the file and we are going to match it with the employee number that user has entered to modify. So, if employee 1 dot get number is equal to e number, then inside this we will call a function emp dot modify which will ask the new details from the user of that particular employee number. ifs dot seekg position will go to the position from where we got that particular record. ifs dot write char star ampersand employee 1 size of the employee 1. So, old record will be overwritten with the new value from the starting position of position. Flag will be equal to true and will come out of the loop using the break and our if condition will end and our while condition will end. So, here it will go on reading the records from a file until the corresponding employee number is found. If the employee number is found that has to be modified, it will ask the new details from the user and it will write it to the file. Now, if flag is equal to f, cout employee record does not exist, cout press any key to exit, exit 1 and if condition will end. ifs.seekg 0, cout the contents of the file are, we are displaying the entire file on the screen, while not ifs.eof, ifs.read char star ampersand employee comma size of employee, employee.display end of the while loop, ifs.close and end of the main program. When the above code is compiled and executed, it will produce the result as first it will ask the records from the user employee number. Suppose the entered value is 101, employee name Ajinkya, department is CS and salary is 25,000. So, it will display the message record is added to the file. It will display the message again to the user as want to enter more. If user says yes, it will ask for the second record details. Suppose the second record entered by the user is employee number 102, employee name Dipali, department electronics, salary is 20,000. Now, it will display the message record is added to the file, want to enter the more record. If user says no, it will stop asking the new records. It will ask enter the employee number whose record is to be modified. Suppose user enter the record as 101. Then it will display the old details as employee number 101, employee name is Ajinkya, department is CS, salary is 25,000. Then it will ask for the new details. New name, enter dot to retain the old name. Suppose the data entered is Ria. New department, press dot to retain old one. Suppose the department entered is PG. New salary, press -1 to retain the old one. Suppose the new salary is 50,000. The contents of the file are, it will display both the records as employee number 101, employee name Ria, department will be PG, salary will be 50,000. Second record will be employee number 102, employee name Dipali, department will be electronics and salary will be 20,000. Error handling during file operations. C++ file streams come into stream state members from the iOS class. that store the information on the status of a file that is being currently used. There are a number of error handling functions that are carried out by class iOS that help to read and practice the group recorded in a file stream. The different functions are integer bad, it returns a non-zero value if an unacceptable operation is attempted. Integer EOF, it returns a non-zero value if end of file is encountered. Integer fail, it returns a non-zero value when an input or output operation has failed. Integer good, it returns a non-zero if no error has occurred. Clear, it recognizes the error state so that more operations can be attempted. These functions may be used in the appropriate place in a program to find the status of a file stream. Now, let's summarize our module working with files. As we have seen in this module, in C++, the input and output operations are performed with the help of streams. The OF stream object is declared for writing to the file or for write purpose, and IF stream object is declared to open the file for reading purpose. In C++, all the files or the streams will be flushed when the program ends. It also closes all the files which are open. In C++, the special function end of file is given, which will return the value non-zero, that is a true value if the end of file is reached. Otherwise, it will return 0, which is basically the false value. The member function get is used to read a single character from the associated stream. The member function put is used to write a single character to the associated stream. The IF stream, like iStream, has a pointer which is known as a get pointer that points to the element to be read in the next input operation. The seekp moves the put pointer to a particular location in the file. The seekg moves the get pointer to a particular location in the file. The tellg returns the position of the get pointer. The tellp returns the position of the put pointer. The parameter offset characterizes the number of bytes the file pointer is to be moved from the location that is specified by the parameter reference position. The iOS : curve present the position of the pointer. The functions that are used to read and write blocks of binary data are read and write. When an object is returned to a file, only the data members are returned to the file and the member functions are not returned to the file. The number of bytes that is to be omitted to access any information is called the offset.